Well, hello everybody. I hope everybody can hear me. If you can hear me, put up your thumb. Thumbs up. Excellent. All right. Welcome everybody to this great opportunity to learn something about greening up to cool down, which is a webinar organized by the Global Evergreening Alliance, of which I am a fellow. My name is Pieter Paap. I am a fellow of the Global Evergreening Alliance, and I work for a company named Farm Tree. But for this day, I am your host at the moment, and I will try to guide you, or I'm the moderator. I will try to guide you through the whole process, but the main presentation will be done by Rob de Laat. So just some pointers before we start off. If you have a question or you have a remark, please put them in the chat so that we know what's going on, and we can come back to them during after the presentation. So during the presentation, Rob will just continue his speech, and then after the presentation, we can take some questions and comments. Also, if you have during the discussion you have a question or you want to raise your hand, just raise your hand via the special button on the Zoom call. And then we can try to accommodate your question during that time. All right. Well, today's, as I indicated, today's meeting has been organized by the Global Evergreening Alliance, which is an alliance of a lot of organizations that are working towards the regreening or the evergreening of landscapes all over the world. And well, as I indicated, Rob is one of the fellows who is very concerned about well, the biotic pump and the function of forest for cooling down the planet, and this is where he will focus his presentation on. Just to indicate who is Rob. Rob is a Dutch-born world traveler, a serial entrepreneur who's building international ecotourism company with partnerships in 17 countries. He's a philosopher, climate activist, rewilding a damaged part of Brazilian rainforest and working to avert the dieback of Amazon rainforest by strengthening the biotic pump over the area. As a principal member of the Eco Restoration Alliance and fellow of the Global Evergreening Alliance, Rob is developing the Cooling Climate Chaos project together with Peter Bunyard and others to reverse the climate crisis fast, working from the Lovelockian Gaia perspective to restore the Earth's metabolism through the restoration of the water cycles and regeneration of the biosphere. 3 tipping points need to be averted right now to avoid wholesale civilizational collapse: the dieback of the Amazon rainforest, the collapse of the ocean biology, and the collapse of the Arctic sea ice. This can be done if the world wakes up and acts as at the speed and scale needed. Now, that's a short introduction of our main speaker today, whom I will give the floor right now, if possible. Yeah. So that will, he will give a presentation for about 30 minutes. And then after 30 minutes, we'll have a good opportunity to have some discussions about what has been presented and maybe answer some of your questions or treat some of your comments. So without further ado, I will give the floor to Rob de Laat, the eco traveler, who will give us a presentation on greening up to cool down and the role of forests in this process. So, Rob, you have the floor.
Thank you, Peter, and thank you for the Global Evergreening Alliance to giving me the opportunity to tell this story. So, hello everybody. Thank you so much for joining and taking the time to listen to this story, which I hope will help solve the climate crisis much faster than what is done right now worldwide, which is obviously too slow, too little, too late for us to get us out of trouble. And I'll dive straight into it. I'm asking the world to come together to repair the climate in a campaign. It is called Green Up to Cool Down, which was started earlier by the Global Evergreening Alliance. And I hope that many, many organizations will join this movement. I'm also a member of the Eco Restoration Alliance, where I learned a lot of what I'm going to say right now. So, but before we start on the Earth, we'll start and make a small visit to the Moon, which is not that far away comparatively. And as you can see here, the climate conditions there are not exactly optimal, with the daytime temperatures as high as 127 degrees centigrade and nighttime or dark side of the moon temperatures as low as 173 degrees centigrade. So while we're almost equidistant to the sun, the climate conditions there are basically horrible and not compatible with life. And that is caused by, well, also the fact that it's rotating slowly, but mainly because there's no atmosphere, there's no water, and there's no life. We're getting a little closer to Mother Earth, and there you see that planet we are part of, and which is teeming with life, is protected by this very thin sliver of atmosphere. Here you see the sun just shining through that little band of gaseous skin that is enveloping our planet, which makes life possible. It protects us against the heat of the sun and the cold of the universe. It's basically, it is in a way a skin that protects all of us, all our species, and provides a lot of the things that we need, like our oxygen, the plant's CO, nitrogen that is also necessary for the biosphere. It produces many other things. The one that I'm just mentioning here, but there's many more aspects, is that it produces stratospheric ozone, which protects us against the worst ultraviolet radiation of the sun. The biosphere produces rain and clouds to protect us and keep the lands irrigated through the water cycles, and I'll tell you more about that. And basically, the atmosphere is a product of the biosphere, is a product of life, carefully designed by 3.8 billion years of life, designing how to protect life itself. We humans have now destroyed half of living biomass, both in the oceans and on land, and that is degrading its capacity to protect life. We're going down to earth, and imagine yourself walking through an old growth forest, and you immediately feel protected. There's something about the atmosphere there. It feels nice. It feels cool. It's never too hot, never too cold. The wind touches the skin in a soft manner. The forest protects you from storms, from heat waves and heavy rain. It collects and cleans water, and it provides a myriad of foods. And nature has been working hundreds of millions of years to design and refine these ecosystems, especially the tropical rainforests, which have been basically evolving for about 100 million years or so. And these ecosystems, if they have time enough, they create the conditions for life to thrive. And that is basically what climate repair is all about, recreating the conditions for life to thrive. Well, zooming out one more time. So here's Earth, our home, and so far the exception to the universe, what we have seen, because it's the only planet that we know that has life. And we're doing basically recreating these conditions for life to thrive with hundreds of millions of species together. Don't forget that, for instance, the oxygen that you are breathing right now is a gift from countless microorganisms in the oceans and from the forest. And all this togetherness creates the temperature regulation of the planet, together with the greenhouse gases, which warm up the planet, but shouldn't do it too much. So how did these perfect circumstances come to be? Well, the key is actually photosynthesis in interaction with water and the atmosphere. We are all very familiar with the process of photosynthesis, where CO2 and water is combined with the energy of the sun into molecules of sugar. and at that time it releases oxygen, and that those sugars are basically the biomass and the food that serves as food for animals. That is the basis of life. But there's one key part, or actually two key parts, that are quite often overlooked, is that for every molecule of sugar created, a couple of hundred of molecules of water, liquid water, is evaporated in the leaves and goes up via the stomata in the leaves, whirls up into the sky. And with that, basically, it packs a lot of heat that was radiated in by the sun, packs it into those evaporated molecules of water, and it whirls up, taking the heat with it back up into the sky, together with a second element of which we still don't know very much, but they are bioaerosols, very small particles that serve as a sort of a landing base for these water molecules to condensate at cloud level. So that when it whirls up together with these aerosols, clouds are made, and then several things happen at the same time. But one of the most important ones is that the moment that the water molecule goes again from vapor to liquid, its volume decreases by a factor of 1,000 or more, which creates an underdraft, and that's under pressure basically pulls up air and pulls up on the side, from the side. And a second thing happens, which is basically separate, is that the energy that's packed in the water vapor molecule now is radiates out at the moment of recondensation. And a large part of that immediately finds its way out into space. It radiates out because it doesn't get absorbed by the greenhouse gases. Some of it will, but that actually warms only the outer atmosphere, the tropopause, and then slowly gets whisked away by the jet streams and then dissipates out into space. So basically, we have a two-step cooling system through evapotranspiration, which starts with photosynthesis in the morning as soon as the sun rays hit the forest and the vegetation around the world. And there's an extra element which is very important in this whole setup, is that when large amounts of trees or forests are together, they have so much evapotranspiration going on and so much cloud forming that this implosion of that water vapor into liquid at cloud form basically makes an under pressure and pulls in moisture from the ocean. And this is the way how forests pull in the moisture that is needed to irrigate the lands. And that's called the biotic pump. It has been for the first time described in 2007 by Anastasia Makrieva and Viktor Gorshkov. And for instance, over the Amazon, a drop of rain gets recycled 6 or 7 times in a process of being evaporated through the leaves, becoming clouds, being whisked away by the wind of the biotic pump, and then falls down as precipitation further down the forest, where it again recycles, and the water recycles again and again, irrigating the continents. If there are no forests, there are no rain and there is no cooling, and actually the precipitation stays over the seas and doesn't get pulled in by this vegetation. So cutting the forest means basically drying out the lands. An example that also was developed by Makareva and Korskov is that the precipitation over river basins, which are forested, are actually it even increases further land inwards. You see here two different graphics. One showed on the bottom the number of kilometers from the ocean, and on the side it's a logarithmic scale, the amount of precipitation per year in millimeters. And then you see, for instance, that the Amazon River, it starts out at around, let's say, 2,000 millimeters at the coastal area, and then goes slowly up in the direction of 3,000 millimeters, 2.5, 3,000 kilometers from the seas because of the biotic pump recycling that water again and again land inwards. On the right-hand side, you see what happens to the precipitation pattern when there is no forest to recycle that rain. And then you see in West Africa, where we start with 1,600 millimeters per year, 1,500 kilometers downwards, basically there's no precipitation whatsoever, and you're basically in the Sahara. So forests create rain and pull in the moisture from the oceans to make that rain. Summing up, forests cool and wet in many ways. Evapotranspiration, creating bioaerosols to condensate that water so that they can make clouds. Once those clouds open up and form, you know, when you're sitting in an airplane, they're very white on the top, so they reflect sunlight back into space. So that's another way how this process is cooling the Earth. It's exporting this solar energy as latent heat. Latent heat is packed into these water vapor molecules and released at cloud level, and then is basically radiated out into space. And it creates this wind and rain via the biotic pump irrigation system to have precipitation deep land inwards. And of course, it sequesters a lot of carbon, which is a problem, obviously, for the planet. It does heat up the planet. But it's this part, the natural part of how the world is cooled via photosynthesis, is actually not really in the current climate models to the extent that it should be. So to cool the planet and also calm the weather, we must restore the biosphere to repair water cycles. And this principle, if we can do that in sufficient amount of places, at the right places, and sufficient amount of sufficient scale, then we are able to stop the crisis, the climate crisis, from increasing. In fact, we can cool down the planet with this principle. So the new climate story, we should look at the Earth differently, see it as a living organism that regulates its own temperature like you and me, and has been at it for hundreds of millions of years to improve the climatic conditions on the planet. This is, of course, as Peter already mentioned, comes from James Lovelock's Gaia theory. And also many indigenous peoples basically see the planet as alive, and all the relationship of the species together, forming these conditions for life to thrive. So to fight the climate chaos that we are seeing accelerating quite fast now, we must restore these damaged ecosystems and mimic nature for food production, because also our food production systems that we have rolled out over billions of hectares is one of the largest reasons why the climate is going the way it's going. So here is an example of, you see the daily cloud forming over the Amazon rainforest, and here over the Congo forest, and you see nothing happens over the Sahara. This is the biotic pump. This is the cooling mechanism, and the irrigation, what happens daily over the forest. Here again, the Amazon. It's very important to see that basically the forest, they breathe clouds with photosynthesis as soon as the sun comes up, and they start doing this cooling process. And this is an overview where you see through the year where most biomass is created. And again, the Amazon and the Congo rainforest, and also the Indonesian forests, are very important in this process. The Northern Hemisphere does well during the Northern Hemisphere summer, but then it dies down during the winter because there's no photosynthesis. And in places like the Sahara, nothing is happening. So that doesn't really help the active cooling of the planet through this process of photosynthesis. Another way of looking at it is to look at the so-called precipitable water, which you can find in the atmosphere. And this is just an average year, 2019. And the light blue colors are the colors where most water is in the atmosphere. The bluer ones is a little bit less, and the brown ones, there's very little. And you can see that it mostly goes in the area of the equator from east to west, and then it bows out on the higher latitudes. It goes basically the other way. And you see that the northern hemisphere, right now we're in March, you can see the tailor going. There's not a lot of precipitation going on, but as soon as the leaves open in the northern hemisphere summer around April, May, you see that the amount of moisture increases. This is basically photosynthesis in action, irrigating the continents. So again, I want to come back to the importance of the Amazon rainforest as the largest planetary cooling organism. It cools the planet right now actively by probably as much or even more than 1 degree centigrade. If it would die back, and that would be an accelerated process, the disturbance to the atmospheric water cycles of the planet and the cloud forming, etc., would be so large that basically we have lost the fight. It's also immense in it produces a lot of oxygen. It could absorb as much as 15% of global greenhouse gases, but right now it's a net emitter because of the damage that has been done. 20% has already been cut, and a lot of the rest is degraded, so its function is already teetering on the brink. And if you understand the amount of water that is recycled there, 25% of all global river discharge goes through the rivers of the Amazon and its tributaries. And there's even more water above the forest than is in the rivers. So it's an enormous system. And this is created by a system that has some of the most extensive biodiversity. Biodiversity is linked to healthy ecosystems, to a powerful evapotranspiration, and creating the right climate for life to thrive. So based on this knowledge, I propose that we start an emergency climate repair plan, which is based on this idea that restoring nature's capacity to regulate water, weather, temperature, and climate by restoring damaged ecosystems to improve the water cycles both on the ground, also above, also the aquifers and in the atmosphere. It's the all this water cycle, all these elements need to be improved. They have been disturbed by us. Where and how much needs to be done in order to have an effect. Okay, here are the emergency measures that need to happen straight away in order to avert basically what I call climate collapse, which is not the collapse of life on Earth, which is the collapse of human societies, because they get so stressed from all the impacts of climate, world's climate events, that they can no longer function. So the first thing that has to happen is a global moratorium on logging of existing natural forest now, not in 2030. It's way too late. Every tree counts. Secondly, I've been working with Peter Banyard in calculating the total process of cooling that comes from restoring forests, especially in the tropical zone. And if we would be able to regenerate 280 million hectares of degraded land, or open field monoculture cropland, and move that to climate smart new landscapes with trees or agroforestry, which would improve the soils, the vegetation, and the water cycles, that would be enough to bring global temperatures down by 1 degree centigrade. And technically, it could be done in 2 decades if everybody was at it. But it would have to be based on a strategic plan, including this biotic pump and precipitation models, because not all forests are equal. There are places which are smarter to start right now than others. So you'd have to have a strategic plan to implement it. And we do have the people who could actually do it because they work with the land, and they are usually underpaid and undervalued. But if we would pay 500 million smallholder farmer families in the global south to repair their lands and transition to sustainable food production, and with that repair the water cycles, we would get this effect and a lot more effects, because they would get income from this repair action. And actually, once they transition to agroforestry systems, they can actually make more money than they do right now, quite often two to even 3 or 4 or 5 times. But at least doubling the income is definitely a possibility. What is outside this webinar is that we also need to restore ecosystems of the oceans fast, and we know roughly how to do that, and we should do that simultaneously. So what if we would repair the vegetation on land and in the oceans, we would absorb gigatons of carbon. But the focus of this climate repair is basically on regeneration of the biology of the planet. So we are part of a large a group of organizations. Global Evergreening Alliance has many organizations. C4ICRA, for instance, is operational in about 50 countries or so. The Eco Restoration Alliance, or ERA as it says here, has a group of about 300 scientists and practitioners with specific solutions to these problems on land and in the waters. We have the solutions to do it. You can make bamboo forest, you can make agroforestry, you can transition to silvopasture, where you do cattle together with the trees. One of the major amazing systems is farmer managed natural regeneration, or FMNR, which has already succeeded in regreening millions of hectares with tree stumps that were still hidden there, underground forests, as they are called, and you can revive them, and then the trees shoot up pretty fast. But in order to do it at such a scale and in a coordinated way, and give people the tool set of how they should deal with their land, I am introducing a tool for regenerative landscape design, which Peter actually is working for. I'm just an ambassador, a voluntary ambassador to the system, because I think it's brilliant. And it's called Farm Tree, and basically you can put in any polygon of land anywhere, and it will propose a regenerative landscape design, and it quantifies the outputs over a couple of years in terms of many indicators. Here are just 6, but I think the total is a couple of dozen, which of course is how the vegetation cover goes, how much CO2 is sequestered, how your nutrients are in the soils, what the yield is of the different products, because it's always multi-crop, what your cash flows are, and how your earnings are, and what effect it has on the water flows. So together, this design tool would be crucial to aid any place on Earth and propose a model for how to regenerate over there. But if we want to do it at the right size, it means we need millions of small projects coordinated in what I call a digital Gaia platform. A lot of the pieces already exist, mind you. We don't have to build it from scratch. Google Earth is one, Restore is one. There's like a dozen out there which already have pieces of the puzzle. But if we can add this regenerative design, landscape design to it, and finance it online without too much with bureaucracy, then we can actually scale this up by people just going on an app, on a telephone, putting their land in. They have to talk to a local organization. You can't do it completely digitally, but anyway, so that they would get the transition finance to do this. The total financing cost of repairing our planet and cooling the planet down by 1 degree centigrade is somewhere between 0.3 and 0.5% of global GDP over a period of 20 years. And what you get for that is global food and water security, lowering temperatures of the planet in general, much less extreme weather events around the world, more income for smallholder farmers, leading to less migration to the big cities and to the global north. And basically, it improves almost all sustainable development goals. So what I call for is a global coalition to green up, to cool down, and make this a mass movement of climate repair everywhere by regenerating the soils, the vegetation, and with that the water cycles everywhere, with a focus on the tropics, but it can be done everywhere. And that's basically the story that I would wanted to tell you. And I would also like to say that we must hurry because we are running out of time. Thank you.
Thank you very much, Rob, for your of course for your even emotional plea for getting this thing started. And well, I say started, but of course the Global Evergreening Alliance and other alliances that are tied to it, they have been working on this concept for a long time already, or at least several years. But I do agree with you that the time is running out, and I guess we can all agree on that. Maybe to kick off some of the questions that have been asked, there is a question from Peter Goebbels in the chat. And Peter asks, Rob, can you expand on your statement that we need to transform agriculture by mimicking nature? How, and do you have examples of where it has been put in practice?
Thank you, Peter. Very, very good question. Let me start with that there are many, usually small examples of where this is happening. For instance, in Andhra Pradesh, there is a movement, well, actually, that's quite big, of a couple of 100,000 farmers that have changed from monocropping to integrated multi-cropping systems. They could put some more trees into the system, but already you see that the hydrology of the area increases, that the humidity of these areas increases, and you have less droughts, and you have less you have also less the temperatures go down, etc. So that has already a lot of these effects. The largest one is actually was triggered by Tony Rinaldo in Niger, and he started in the 1970s and worked with a couple of villages to do FMNR, basically reviving the tree stumps that were there that were removed for monoculture cropping. And it was actually, I think, maybe somewhere at the end of the 80s that satellites found that that system had spread over a couple of millions of hectares in that area, because the greening up through the growth of these tree systems together with crops was so beneficial to the locals that it was that everybody was already starting it without any outside help, in fact. And precipitation has gone up in this area, as far as I know. So these are two, but there's many other examples. I myself have done a very amateurish thing in a small valley in Brazil, basically rewilding it, and I've seen the incredible metamorphosis within years. I hope that's enough answer for now. Thank you.
I guess Peter has asked a follow-up question, and he says, and in your response, can you mention how to mimic in dryland areas like the Sahel? You've given one example of the farmer managed natural regeneration in Niger already, but would you know of any other good examples here, for instance, in other regions than let's say the Sahel area?
Well, if you look at the drier areas, I think let me first remind something that Douglas Schill, he's a professor in Wageningen and one of the top specialists in the world. He always says the right tree in the right place. That means tropical rainforest is clear; they have a completely 100% covered canopy, but drier areas have intermittent canopy. So it depends very much on where you are, what the exact design should be. And there you mimic nature. You look at how the system was before we basically transformed it in such a way that before with our monocultures and stuff like that. And you look at that and you mimic these things. I know, for instance, that silvopasture, so that's basically cows under trees, if I can put it that simply, can increase the growth of the cows by up to 50%. And at the same time, and that's more important for us, it does all the evapotranspiration, increased precipitation, moisture holding in the soils, and the increase of the soil quality and the microbiology, which is basically that is what climate is made. Good climate is made of these holy of these healthy systems.
All right, thanks, Rob. We have two hands up. First, we have Roger Leakey, who put up his hand, so maybe he can ask his questions. A question if he can unmute.
Hi, can you hear me?
Yep.
Hello,
Rob. Rob, you implied that climate is constant throughout the year, or at least you didn't say it wasn't. And of course, we all know that precipitation is seasonal, with wet and dry seasons, and that's regulated by atmospheric pressure and the highs and lows of atmospheric pressure. So rain, if you get a high pressure over a continent, as you can very easily in Australia, for example, get the whole continent covered by high pressure, then the rain is never going to be drawn onto the continent because all the low systems get pushed out and they rain along the coast or out to sea. So it seems to me that your presentation didn't really take that into account, that we need to be looking at how to alter the albedo of the land so that high pressure systems don't develop so strongly or don't last for such a long time, so that we can get the moisture drawn in over the vegetation in the ways you describe.
Thank you, Roger. Yeah, you're absolutely right. That wasn't part of the presentation. Mind you, it was a 30-minute presentation. We could go on just about this aspect for another hour. I would say that if you look specifically at Australia, that the coastal the forests that have been removed since, what is it, 1776, basically have done a lot to stop the biotic pump from functioning. Especially, I would say that on the east side and the southeast side, not so much in the north because there's still rainforest. But anyway, so if that would be restored with good ecosystems with a lot of trees, then that would pull in the moisture, and then you get your biotic pump working, which basically it makes under pressure because of the evapotranspiration and cloud forming, and then slowly that system would start raining more and more in. So we're talking about landscape design, not just at small levels, but basically there should be regional and even continental plans where there are important areas where you would start doing this greening in such a way that the moisture gets pulled in. So I think there's absolutely possibilities, and almost certain the climate conditions in Australia have been degraded a lot because of large-scale removal of original vegetation.
But would not the revegetation of the red centre of Australia have a much greater effect than tinkering around with the forests, the wetter forests along the edge?
Honestly, we're coming in an area where we don't have enough information yet. I would love to have Anastasia Makareyeva, Douglas Scheel, Peter Banyard here. But in the end, moisture can only be recycled if it's there. And the moisture would have to come from pulling in from the oceans first of all. So and the funny thing is, for instance, we looked at some modeling, but it's very premature. But you don't need a full canopy cover. A certain amount of canopy can already be enough to pull this moisture in. And definitely, if you get a forest large enough in the center, which has enough moisture, then it would rain on itself for sure. I recently read, for instance, that evapotranspiration increases by, photosynthesis increases by about 40% if the aquifers are filled enough, so that the roots have enough water to suck up, so that there's enough photosynthesis, evapotranspiration, cloud forming, etc. So even localized it could be, but you need a sort of a minimum size in order to get your perspiration pump going.
All right.
Thanks.
I hope, Roger, that gives you a little bit of a better view on Rob's ideas about the biotic pump in that area. I also saw a Blessing's hand up, but I don't see it anymore. Blessing.
Yeah,
Are you with
thanks
us?
a lot. Mine is, yeah, can you hear me?
Yes.
Okay, yeah, thanks a lot, Rob, for the presentation. And I'm very much in line with that, especially in Malawi, that we have been greatly affected by El Nino, issues of drought and what have you. So some of the recommendations and issues of agroforestry is something which can really come in and support. But my question mostly goes to silvopasture, where I want to just find out on the, do we have the recommendations of number of cattle versus the hectarage? Because one of the challenges in Malawi in most of the areas is overstocking and overgrazing. So I just wanted to find out if we've got that ratio, which can be applicable for all of us. The second thing is it very much positive in areas like the tropics, like Sub-Saharan Africa?
Oh, Blessings, you're dropping away.
Voice is gone. Blessings, are you there?
In the area where it has been proved that it is really doing. Yes, can you hear me?
I can hear you now.
Can you hear me now?
Yeah, Blessings. Thank you, my friend.
Yeah.
It's good to see you here. And
yeah, you can hear me now, yeah?
Yeah, you were gone. Yeah, go on.
Yeah, the first part was just a comment on agroforestry, of which is very much positive in Sub-Saharan Africa, like in Malawi. But the question was on the ratio. In most of the past in Malawi, we have got a problem of
yeah, I think Blessings. Let me just comment on what I've heard so far. I think it's better to.
So do we have rand? Yes, that one. Yeah.
Yeah, Blessings, you're in and out every now and then, but thank you for your question. I'm going to comment a little bit, although I'm not sure if I heard all the questions completely. If I look at South Malawi, we have been talking about it, you and I. Actually, you see that there is a clear a drought flood cycle going on, and that has a lot to do with the removal of canopy. I would say in large part, actually, more on the east side in the Mozambican coast, where there has been a large deforestation for the last 20, 30 years or so. And so while if a good forest cover basically not only brings rain, it also brings temperate rains, and it absorbs those rains better because of the better soil, so it can infiltrate into aquifers. If you take them away, then all these effects they get worse. So when the rain falls, because the air is really super saturated, it falls in one time, then it rushes off, and it creates a lot of problems. So I think that I think that the restoration of Southern Africa, which of course is in a terrible drought right now, should need a complete plan, and then go back to the smaller areas to repair the climate overall. And one of the things certainly is the repairing the canopy on the Mozambican side. That would be one of the first things I would think you have to look at. But local reforestation and agroforestry is obviously very important anyway. It all has to happen. This is a large project. This is the largest project humanity has ever undertaken, regenerating the biology of the planet. But we don't have many options left.
All right, thanks, Rob, for your answer. I hope Blessings is content with that answer. I have a comment from Antoine in the chat, which says sustainable management of forest needs a recognition of ownership of such ecosystems by indigenous people and local communities. Rob, can you say a little bit about your experiences with involving the indigenous people and local communities in the activities that you've been doing with regards to the biotic pump?
Yeah, and I can say that so far I didn't have a lot of great experiences for all kinds of reasons. But for instance, in Brazil, luckily, a lot of the indigenous territories are officially they're officially recognized with recognized borders, which is different than in other places in the world. At the same time, you see that there is a lot of red tape. There's a lot of greedy people that like to make money on carbon credits. And so I must say that right now it's a wild west. That in some cases it does work well. For instance, in Acre, where I'm not involved, but I know that in the state of Acre in in West Brazil, some things are going well, but other places you see that it's really badly organized. And that's why actually that digital Gaia plan is important, because it would do away with all the reporting and the feasibility studies, etc. You have to get your FPIC organized. You have to get the involvement of people and their consent and they have to see how they can benefit. But apart from that, the following of the growth of the biomass and paying for that in carbon credits can really already be automated, and we should go straight away to it.
Thank you. I have a question from Simon. Maybe he wants to take the floor.
Thanks, Peter, and thanks, Rob, for a great presentation. I think it's so important that we put this on the map, and you're very effective in doing it. One thing that in my understanding, the data on the Amazon biotic pump is a lot better and a lot more proven scientifically than the data on the Congo Basin pump. I've seen publications that surmise, which I think is very a logical assumption, that the better recovery of rainfall in the eastern and the central Sahel compared to the western Sahel is linked to better forest conservation in the Congo Basin compared to the West African coast, where we've lost a lot of forest over the last 4 or 5 decades. But it would be good to somehow get the data, out there. The current reward for forest conservation in our forest carbon systems is almost non-existent, right? And you have countries like Gabon that sequester a lot of carbon in their standing forest, also because those forests are disturbed ecosystems, right? There were people that farmed through them between 600 and 1200 years ago, as we now know, and so they're nowhere near a climax vegetation. compared to the Amazon, for example, the wood is less dense. You know, there's more non-pioneer light demanding species in the Congo Basin forest than in the Amazon forest. So very clear differences. It would be, yeah, we really need to reward these countries for keeping forests, for conserving them. I'm very much against a global ban on logging in natural forests. To me, it really depends on the standards that are applied and how selective it is. But so if you could comment on, you know, do we really need one, how can we get better research for Africa, for the Congo Basin, so that we can put this on the table with people and get the climate adaptation funds unblocked that we need? And second, you know, I don't think that for the Congo Basin we need a full logging ban, and it may actually create a lot of opposition for us, and it may block us from mobilizing certain allies. So thanks, but thanks for a great presentation. Really appreciate it.
Thank you, Simon, and thank you for your words, and thank you for your remarks. Yeah, I think, let me first say, there is such a thing as sustainable logging, which basically can be defined and has been defined as in certain areas. So I'm in that sense, I'm against the removal of large forest areas. That's a better way of putting it. And of course, you can do still sustainable logging, but you have to control that very well. And you know that's not so easy in these areas. With regards to the Congo, there's actually one very interesting thing, and I don't know exactly where the research is, but I've seen it. Is that if you look at where the moisture comes into the Amazon rainforest, it's on the northeast side, but that goes with the trade winds in the same direction. But in front of the Congo rainforest, you can actually see that the biotic pump at times is so strong that it bends the trade winds into the opposite direction, pulling in the moisture from the Atlantic Ocean, proving that it is. The last remark that I would like to say is that Peter Banyard and I have written an article, and we came to the conclusion that the cooling capacity in the tropical rainforest, which is different than other ecosystems because they are really the cooling organs of the planet, the cooling capacity of the rainforest is a factor 100 times bigger through the water cycle than through the carbon cycle. So once we realize that, I think those carbon credits are going to be worth a hell of a lot more.
Thanks, Rob. I think we have time for one more question before the hour passes us by. I see John Dixon's hand up, so maybe he can ask the last question that we have time for now. And then, well, if there are other questions, please just send them to us via email, and we will try to accommodate that way. So, John, you have the floor.
First, thanks, Rob, for a really excellent presentation, really magnificent, very useful. Well done for all of our fellows and the wider audiences. Secondly, I want to thank you for bringing into the picture the 500 million families, or the 2.5 billion people living in rural areas who are influenced by whatever forest or landscape changes will happen, for better or for worse. That's a major part of our global population who's directly impacted in terms of livelihoods. So that's excellent. The key piece, I would like to say, I'd be keen to continue a conversation in terms of this, of your estimates about the 1 degree drop with Rob Barnum, and requiring only 0.3 to 0.5% of global GDP, etc. Fascinating, but I think that is worth pursuing further. But the real question you probably have a quick answer to right now is which, so far as you know at this time, the likely priority forests for restoration. You mentioned that Amazon is one, of course, but after Amazon, would it be Indonesia Borneo, etc. next? Could you suggest which are the top 3 or 5 that we should be thinking about? Thank you very much.
Yes,
Rob.
John, thank you for your encouraging word coming from you. That's really means something to me, because I know how long you've been working on these kind of things. But thank you. Yes, of course. After the Amazon, I think what we have to do globally, look at it. We know Borneo, of course, precipitation is already down by 20% caused by deforestation and putting palm oil plantations in, of course. But I would say that the whole stream, the buildup of the Indian monsoon, and from there going over over Pakistan and then into the Arabian Peninsula and connecting to the African water streams, the Horn of Africa, and which has been damaged. That's why it's so dry. I mean, we all know that actually the Arabian Peninsula and Mesopotamia and stuff were partially forested just what is it 4,000 or 5,000 years ago, and probably the deforestation that happened on the east side of it cut the biotic pump, dried it out. So the largest global effort should be to get the Indian moisture over the continent flowing again and connecting to the African moisture streams and also to the Mediterranean, which you probably know that Ties van der Hoeven is busy with that part. So those disruptions which are obstacles to the total precipitation pattern should be worked at and could have amazing effects, I think. Peter, you're muted.
I'm muted. Yeah, I muted myself. Excuse me. I hope John is satisfied with that answer. There are various regions that probably would be spear points to do this type of restoration. So yeah, thanks Rob for your answers. We are past the hour that was allotted to our webinar. So I would say thank you all for joining us. Thank you, Rob, for an excellent presentation, and thank you all participants for your time and also for the interesting questions which are strengthening and deepening our understanding, and also give us a little bit of pointers towards where we should be looking next. We have from the Global Evergreening Alliance, we have various working groups that are working on certain topics that are related to what Rob has been discussing. So if you are interested in knowing more or getting involved, please let us know, and we'll try to rope you in, get you up to speed, and see if we can together we can find some of the solutions that Rob has been suggesting. For now, I would say also thank you, Secretariat of the Alliance, for making this possible. Sally, Natasha, and Katerina, thanks for helping us in setting this up. And we will be sharing the recording of this webinar via the email, and probably we will try also to put it in a LinkedIn message to which probably some people have responded, getting to know about this webinar, so that you can look back and see if there are any possible things that are of interest to you, and you would want to follow up. I don't know, Rob, can we share the presentation?
Please.
Or would you...
Of course, I'd like this story to go out as wide as possible.
All right. Then we'll try. It's a big presentation, but we'll try to put it in some repository, and then see if people can access it. So for now, I would say thank you all for being here, and we hope to see you again during some next webinar meeting, or maybe on an activity that has been organized by the Global Evergreening Alliance. So with these words, I say cooling up to green down. Oh no, greening up to cool down.